I'm going to show you how to use the multimeter to investigate a light dependent resistor and a thermistor. Two different components whose resistance changes with the external conditions. So the first thing I'll do is I'll plug my light dependent resistor in. And because I'm measuring resistance, I'm using the COM, the bottom of the socket. And I'm using the middle socket, the V, ohms and milliamp sockets. That means my scale is okay. I'm now going to move my dial from the off position down to reading resistance, and the resistance goes from 200, 2000, 20,000, 200,000 to 2 million ohms. Personally, I always go to the lowest possible reading I can and then move my scale upwards. So what you can see is that the resistance of my light dependent resistor, current amount of light it's got, is off the scale here. Still off the scale, still off the scale. Right, we're just starting to get a reading on the 20,000 ohms. So we're looking at around 7,000 ohms, 7.5. So what happens if I go up the next level? I've gone to read 7.7 thousand ohms. So this is probably my most accurate level that I can get. I can't tell you why this is changing in reading. I can only assume that the light levels are fluctuating slightly, but it's around that 6,000 to 8,000 ohms or so, 6,000 to 7,000 ohms. If I open my window and we make this brighter, you can see that the resistance now has fallen by about a factor of 10 actually, isn't it? Let's just move my dial down and we can see what we're reading. It is about 860 ohms, okay? And if I make this dark again, but I cover this up with my thumb as tight as I can. Obviously the scale, it's got higher resistance, and we're now up actually by another factor of 10 to sort of 67,000 ohms ish, about that sort of level. Okay, so that's my light dependent resistor. If you were doing this as an experiment, you probably would have a more controlled light source, and you would probably be measuring how far away your light dependent resistor was from the light source, for example, to try and get some sort of data. But this is really just for a straightforward comparison. Here now I've got my thermistor. So again, I'm putting the one end into the COM socket and the second end into the middle. So my thermistor is a device, and the temperature, the resistance of the device depends on the temperature. I can see that if I go down a notch, you can see the reading at room temperature. I've got a scale here. So room temperature about 23 degrees. My reading for this thermistor is about 460, 450. I've got some cold water here. If I take the reading of the water, so it was about 25, we're now about 21, 22 degrees. What happens to the resistance when I put my thermistor in here? And you can see that that increases. So I'm cooling my thermistor down, putting it in colder water, and my reading is increasing. I've now got some warm water here. So I'll take that reading. So I'm just pressing my infrared thermometer. So you can see the reading I'm getting of the water, pointing the thermometer at the surface of the water, put my thermistor in and see what happens to the resistance. I have to leave it in there to settle down, for the reading to settle down, wait for the whole thermistor to cool, warm up even. Okay, so we've got a reading there. And my final reading, I've got some water I've had in the thermos. I'm not sure how hot it is. Let's see. Oh, it's only about 45 degrees, so it's a bit hotter than we were. What's going to happen to my reading? Have a think with the pattern you've seen already. Warming my thermistor up, and you can see what the temperature's going down to. You might want to give a little stir if you're doing an experiment where you're adding water in drips and drabs to maybe warm it up, to make sure there is proper mixing, and then wait for your temperature to settle down and then take your readings.